Something came into our solar system in 2017. It didn't send a signal, it didn't make a sound, it just appeared, moving faster than anything we had ever tracked, coming from a direction in space where there was nothing. No star, no planet, no known source. Scientists watched it for 11 days before it disappeared back into the darkness. And to this day, we still don't fully know what it was. This is the real story of Oumuamua, the first interstellar visitor ever detected by human beings, and the object that quietly divided the scientific community in ways we almost never talk about. It was October 19, 2017. A telescope in Hawaii, called the Pan-STARRS telescope, was doing what it does every single night, scanning the sky, looking for asteroids, comets, anything unusual moving through our solar system. And then it found something. An object moving incredibly fast, already past the sun, already heading back out toward deep space. The scientist who first analyzed the data, Robert Warwick, looked at the numbers and immediately knew something was wrong. Not wrong like there was an error, wrong like this doesn't fit anything we know. The object had already made its closest pass to the sun before we even noticed it. By the time the world's best telescopes turned toward it, it was leaving, moving away from us at about 87,000 kilometers per hour. They named it Oumuamua, a Hawaiian word that roughly means a messenger from far away arriving first. And when they traced its path backward, back through the solar system, back past the sun, they realized it hadn't come from anywhere inside our solar system. It came from outside, from interstellar space, from between the stars. That had never happened before. In all of recorded history, no object had ever been confirmed to come from another star system until this one. Now, finding an object from another star system would be incredible enough on its own, but Oumuamua didn't stop there. The more scientists studied it, the stranger it got. First, the shape. Based on how its brightness changed as it tumbled through space, scientists concluded that Oumuamua was extremely elongated, possibly 5 to 10 times longer than it was wide. Some estimates put it at roughly 400 meters long and only 40 meters wide. That's like, imagine a skyscraper. Now imagine that skyscraper flying sideways through space. No natural asteroid we have ever seen looks like that. Second, it was moving without any visible reason. When objects fall toward the sun and then fly away, we can calculate exactly how gravity will affect their speed and trajectory. We are very good at this. We have been doing it for centuries. But Oumuamua wasn't following the rules. It was accelerating, speeding up, in a way that gravity alone could not explain. Now, when a comet does something like this, we know why. Ice on the surface heats up, turns to gas, and that outgassing acts like a tiny rocket. Scientists call it non-gravitational acceleration. We see it all the time. So scientists looked for that. They looked for the trail, the cloud of gas or dust that would explain the extra push. There was nothing. No tail, no cloud, no outgassing. Just clean, unexplained acceleration. That's when things got really interesting.
Most scientists, when confronted with something they can't explain, will say one of two things. Either we need more data, or there must be a natural explanation we haven't found yet. Avi Loeb said something different. Avi Loeb is not a fringe scientist. He's not someone you dismiss easily. He was the chair of the astronomy department at Harvard University for 9 years, one of the most cited astrophysicists in the world. And in 2018, he co-authored a serious scientific paper published in a peer-reviewed journal suggesting that Oumuamua's acceleration could be explained by something remarkable: a light sail. The possibility that Oumuamua was a thin, flat, manufactured object, pushed by the pressure of sunlight the way a sailboat is pushed by wind. The same concept that NASA and other agencies have actually experimented with for real spacecraft. And because such a sail would be incredibly thin, almost like a sheet, it would produce very little outgassing. No tail, no cloud, just silent, clean acceleration. He wasn't saying it was aliens. He was saying we should not rule it out, and that the data is consistent with an artificial object. The scientific community pushed back hard. Many colleagues were not happy. They called it irresponsible. They proposed alternative explanations: hydrogen ice, frozen nitrogen, unusual dust structures. But here's the thing that stays with me. Every alternative explanation they offered had its own problems. Hydrogen ice would have evaporated too quickly. Frozen nitrogen would require a process we have never observed, and none of them have ever been confirmed. As of today, no one has definitively explained what Oumuamua was. Let me tell you what we actually know for certain. Oumuamua came from the direction of the constellation Lyra. It passed through our solar system in roughly 11 days of close observation. It was tumbling, rotating every 7 to 8 hours. It was reddish in color, similar to objects that have been exposed to cosmic radiation for a very long time. And then it left, moving at escape velocity, heading back into interstellar space, never to return. We couldn't send a spacecraft after it, not in time, not with anything we have. By the time we understood what we were looking at, it was already gone. And here's the part that I think is worth sitting with for a moment. Oumuamua was only detected because it passed extremely close to us in cosmic terms. Scientists estimate that objects like this probably pass through the inner solar system roughly once a year, but our telescopes almost never catch them, which means this may not have been the first time something like this passed through. We just weren't watching. Avi Loeb has since started an entire research project called the Galileo Project, dedicated specifically to watching, looking for objects like Oumuamua, trying to catch the next one before it disappears. Because if there is a next one, and there probably will be, we want to be ready. So what was Oumuamua? Was it a strange, cigar-shaped rock that formed around another star billions of years ago and drifted into our neighborhood purely by chance? Maybe. Was it a thin sheet of material, natural or artificial, catching the sunlight like a sail? Possibly. Was it something we don't even have a category for yet? That's the answer I find most honest. What I keep coming back to is this. The universe is 13.8 billion years old. Our civilization has been sending radio signals into space for about 100 years. We've been pointing Sirius telescopes at the sky for maybe a few decades. In that tiny sliver of time, something came through. Something we had never seen before. Something that didn't follow the rules. Something that came from the space between stars and passed through our little corner of the solar system and left without a trace. Maybe it was just a rock, but maybe for 11 days in October of 2017, we were closer to an answer than we realized. Thank you for watching. If this kind of story keeps you up at night the way it keeps me up, you are in the right place. Subscribe, and I will see you in the next one.